So in this lesson today, we are going to learn about rationalising the denominator of a surd. So at the moment, you should be able to see that in question A here, which is 3 over root 2, the denominator, meaning the number down the bottom, the root 2, is a surd. By rationalising the denominator, we're going to change it into a whole number. Okay, so 3 over root 2. You have to think about what can I do to the square root 2 to make it a whole number. Well, if you square a square root or a surd, you are going to get rid of it and make it a whole number again. And I guess what is the opposite of taking the square root of 2 would be to square it. So we can write that as 3 over root 2 times. Now, if we're going to make square root 2 become the number 2, a whole number, we are going to times it by square root 2, because square root 2 times square root 2 gives the square root of 4, which will then become 2. But I can't just times something by root 2 because that's not really correct. The correct thing would be to also multiply by square root 2 on the top, because essentially this thing in here, that's just 1. So we're not really changing the number if we're just multiplying it by 1. All we're doing is changing the denominator. So multiplying across, as we do with fractions, multiply the top together, then multiply the bottom together. 3 times root 2 all over. Now, square root 2 times square root 2 is square root of 4. And once you do a few of these a couple times, you actually become a lot quicker and you can say straight away, yeah, that's going to be 2. But for the purpose of explaining the first example in this video, I'll leave it as the square root of 4. So 3 times root 2, now remember when we're doing surds, and like we do with algebra as well, we leave off the multiplication symbol and it would become 3 root 2 all over 2. Okay, and that is our first example in there. And we can't simplify that any further because this square root here is by itself, it's a surd in itself, so we can't actually simplify it with the 2 down the bottom. So that is your final answer there, 3 root 2 all over 2. So looking on to part B up here, in this case the only surd that we have is the square root 3. Leave the 4 separate and just think about the square root 3. How can we change square root 3 to become a whole number? So we have 5 over 4 root 3 times square root 3 on square root 3. Like I said over here, you will get quicker at doing these as we go. Okay, so I'm not going to write the times symbol in as I did over here. I'm just going to go straight to writing 5 root 3. So 5 root 3 over 4. Now, root 3 times root 3, root 9. So we have 5 square root 3 all over 4 times 3. And then 5 root 3 all over 12. And once again, this cannot be simplified. The root 3 does not cancel out with a 3 as a factor of 12 because it is a surd. It's a little bit tricky now actually. A lot of students will get confused with this because we have the square root 2 on top and the square root 5 on the bottom. Just focus on the bottom because we are focusing on the denominator. When you have a number on the top, just ignore it and we're just going to look at the square root of 5. Once again, how do we get rid of a square root 5? Well, we would multiply it by itself, as in squaring it, and we have to also multiply that by square root 5 on the top. So 8 times square root 10, because 2 times 5 gives me 10, and we can only multiply what's underneath the square root. That's just basic Surds, which you would have learnt last year in the Year 9 course. And then 3 times square root 25. Once again, I'm doing it a little bit slower for the purpose of this video, but if you wanted to, you could write down 3 times 5 straight away. 8 times square root 10 all over 3 times 5. So 8 square root 10 all over 15. And once again, we can't simplify because we have 8 and 15. They don't have any common factors. The 10 and 15 do have common factors, but because the 10 is underneath this square root symbol, we are unable to do that at this stage. Square root 2 plus 1 all over square root 3. Now just remember that you only are looking at the bottom, the denominator. You're asked to rationalise the denominator. How can you change that square root 3 to become a 3? To get rid of the square root sign, you square it or times it by itself. Okay, now a lot of students might get confused here because we've got this binomial, in which case I'm just going to write it with this notation. So 3 times bracket square root 2 plus 1. So I'm actually multiplying 3 by all of this, not just the root 2 and not just the 1, but the whole thing in there. Okay, and I'll show you how to do that in a moment. And then on the bottom we will have the square root of 9, because 3 times 3 is 9, and once again you can write down 3 straight away, that's up to you. Expanding this, so some people like to draw a line in, so 3 times root 2 and 3 times 1, you can do that, that's perfectly fine. 3 times 2 gives 6, so square root 6 plus square root 3 times 1. Well, technically it's 1 root 3, but I'll clean that up in a moment anyway, just showing you why. And the square root of 9 gives 3. Now this thing here, it's sort of like writing 1x, and we know that in algebra we don't write 1x, it's just x, and we learnt that with Surds last year as well, it's just root 3. So we have square root of 6 plus square root 3 all over 3, and it looks like we could maybe simplify it, but unfortunately because the 6 and the 3 on top are underneath their own separate square root signs, we're unable to actually cancel out a factor of 3 between everything in there. So that's it for those examples. We're going to do some examples, some more work in class tomorrow. So come prepared with any questions. Thank you.